Okay, welcome everyone to my first ever live stream. Hopefully we're going to start building a game from scratch in C, and I'm going to show the whole process, and we're going to learn a lot and hopefully have a lot of fun too. When I released my first big commercial game called Ilios' Hunt, we released it for PS4 and PC on 2017. So I realized that I didn't actually know what I was doing in terms of programming. But we released the game, and that was really hard, but we did it. And so when we did finally release, I was like, okay, I think I'm going to take a step back and actually learn programming for real. So at that time, I started to program, with no engines to really learn and start having fun. And that's why I found the C programming language more interesting. And so that was the challenge. Making it as a hobby, I decided to go deeper into the programming as well as the design. So it's trying crazy things like that. So I think now I'm going to do one step further than that and actually do a more complex game than I did with Pong. So we have like a lower benchmark, which is what I did in that case, and we can build on top of that. Okay, so as you can see, it's a simple game, but it was built all using C, and we're going to kind of based our ideas upon that as a minimum level. But I think you can experiment with more things like bitmaps, and this uses like async audio, and that was pretty cool. So we're going to build, so this is kind of the idea that we're going to build, but more complex in terms of design and in terms of programming. Okay, so that's what we're building. So we're going to build a breakout-like kind of game. We're gonna, like we started with Pong and then built upon that in game design ideas. We're gonna do that same with Breakout. We're gonna start with a Breakout clone. Then we're gonna do some pretty interesting game design things, I think. Okay, so first thing we're gonna do is a platform layer, and it's gonna be Win32. Okay, we're gonna do this simple things like we're gonna do the window, we're gonna do the input, we're gonna do the rendering. We're going to experiment with the gameplay. We're going to build the Breakout clone and then start doing some semantic compression, see what works. So after we play around a bit with the gameplay, we're going to do a more robust engine pass. So we're going to start doing bitmaps and audio and things like that, multi-threading things, just to make sure that all the ideas that come up when we experiment with the gameplay will be able to be expressed through the game engine. And then we're going to do a more gameplay. We're going to do a more focused gameplay stage at this point. We're going to, create levels, different levels. You see that I have a lot of ideas, and maybe you guys will be able to come up with ideas too. And then at the end, we're going to do a polish pass to publish the game. The first thing we're going to do is just to make sure that the compilation works and everything's smooth. We're going to do a simple hello world program. I'm going to do actually a hello sailor. Sailor. Okay. So if I try to run, I have the hello sailor. Okay, so this is the basic setup we're going to do. And now we're going to start actually building the game. So to build a window in Windows, so this is the entry point of our application. The call we want to do to create a window is create window EX in MSDN. Okay, so this is the basic thing we want to do to create a window, and returns a window handle and a class name. Okay, so that's the thing. Before creating a window, we have to create a window class, the window procedure, because the way it works on Windows is that we have callbacks all the time for the window messages. So the window class, we have to create a procedure specified like this. Okay, and this procedure, we're going to pass it as a pointer here. And this is going to receive all the messages, the main messages. We can also, peek message. We're going to do that for input, but we have to do this. Okay. Then we're going to register the class. We're going to pass this the window class, the pointer. Okay, and then we're going to finish our create window. Okay, let's see what we have. I'm going to try launching the build. Okay, and yeah, you guys can see, right, there's a window. It's popping up really fast. That's what we wanted for the time we created the window. It's not much code, and it's like the first time we're doing this, right? Because I could have copied it from another place. And okay, so that's a start. Now we're going to loop. Actually, what I'm going to do is I'm going to define like true and false, just so it's easy. And then we can type def, bool, and stuff. Now we're going to do it while running. And this is the main loop of the program. So that basic thing of input, simulation, and render that games are structured, that's what we're going to do. For input, we're going to create a message, and we're going to call peak message A. Okay. So all the messages are coming through here. Okay. So now we can treat them. We're going to do a switch on the message, and in case it's like a WM close or a WM destroy, we are going to set running to false. We should be able to actually close the window, make it full screen, all that stuff, because we're going to keep reading the messages in the main loop, in the infinite loop. And here, the close and destroy message will actually stop the game from running. Going to turn the running to false, and then it's going to stop. That's the basic idea. Let's see what happens when we try to run the game. Okay, so we have the window. We can move it all right. We can make it full screen. We can change the size, minimize it, and close. Okay, so window is done. Now we need to render to that window. We need a buffer, which is basically some memory that we can draw to. Okay, so this is the Windows part. It's going to give us the memory, and the draw part is up to us, up to the game. Use the buffer, like draw to the screen. And this use the buffer, we can use like the stretch the ibits call, which is our starting point in order to look at the documentation, and that's the rendering. Right? This is the pixels. Remember when I told you that we need the memory and give that memory to Windows? This is the memory. I'm going to call this memory. And then it needs a bitmap info. And now I have to fill those. Since all those refer to our buffer, to our, let's say, rendering buffer, I'm going to create a struct for that. And since we just created all these type defs, I'm also going to include std int.h, I believe that's so. Yes. And then I'm going to do type def. Okay, and actually this thing is I'm going to make our first actually file called utilities, utils or utilities.c. Now we are looking good. Now all I have to do is fill this thing with this struct with useful data. And this is in the case of a change in size of the window. The basic idea is to get width and height, and then allocate the buffer, and of course, fill the bitmap info. Okay, now maybe a good time for us to start debugging our program. The width is 1280 and the height is 720. So this is the basic setup we need. Okay, so we got the window size, width and height. All right. Now with that we can allocate the pixels. Okay, so this is the basic thing that we need. Now we're going to have to fill the bitmap info. Okay. Now I'm not sure what's going to happen, so we're going to step in the debugger just to make sure that nothing explodes. Okay, so the width and height is as we expected, and we should have no pixel, so we're not going to free. Okay, so if I calculate, yeah, let me just see pixels. Yeah, so we do have a bunch of memory, and it's 0, so we can do all the things we want. So if we display this memory, we expect a black screen at this point. Let's just see what we see. A size of the struct, okay, width, height, claims to 1, big count to 32, compression to the RGB, which is 0, so we could just do nothing. So let's see if we have a black screen. We do have a black screen. And if you change size, it automatically allocates and deallocates. Let me put a breakpoint here. So I'm going to put it full screen. See, so it stopped here because we do have pixels. So we're going to free the pixels, and then we're going to allocate the new size. Now we should be able to create our own rendering functions to like change the color and do pixel things. Now it's going to start being interesting. You know, we're going to exit the Windows part. We're going to create a new file. I'm going to call this software rendering.c. And as I told you, we're doing a Unity build, so all the files are included here. So I'm going to include the whole C file. Software rendering.c. And for now, we're going to have a basic function. I'm going to do a internal void clear screen. Now, if we come here in the simulation part and call the clear screen, passing, I don't know, let's do a orange. Hopefully, we'll see an orange screen. Let's see. I'm sorry, that was a yellow screen, and it's not actually working too nicely. You only feel like about a little bit over half the screen. Actually, we're setting a fixed number of pixels. Okay. First of all, let's do it orange, just for fun. And yeah, because you did high twice. Okay. Copy and paste bug. Typical. Okay, now let's see if we have an orange screen. Okay, now you can see the orange screen. And now hopefully you can see that all we need to do now is to do like helper functions. Let's see. Okay, now we see our yellow rectangle. Is the position correct? I guess. I mean, starting at 50-50 and going to 150, 200. I'm not sure though. I kind of expected it to be the same distance, the start here. See, now it looks correct. Yeah, I'm also going to clip. We're coming along, right? Okay. Yeah, I do think it's correct. I'm not sure why putting close here was a problem. We can test it more, calmly later on. Just excited to get things on the screen. Now, what we are going to do is just have a basic input system to be able to control this. I'm going to make it a little bit smaller, right? To be able to control this guy with our keyboard input. Now, we do have the big message here, and we can do a switch on the message.message, I believe. Let's see. Yes. And if the message is a window message of key down, we're going to do character equals true. We're going to, improve on that just to start iterating. Okay? Now, so no character, I'm going to press left, and we do see the character. Because now we have the basics of we need. We have the input, we have the rendering, and we have the windows, the window, right? And now we're going to improve on that as well. So it's not done for the gameplay, but we are going to do all of them at once, I suppose. So what I am going to do now is, in our folder here, I'm going to create a game.c file. So that's what we're going to do. We're going to do the simulate game here. And for now, just as a cheat, we're going to pass the input, in quotes, right, to the game, which is now just this variable we created. And the game can now do the simulate game. We're going to receive the move character. Okay? And if move character, do this. So this is the basic structure. We're going to have a platform common file. This is the specification of what the platform layer uses to interact with the game. For example, we're going to have a input struct. We're going to pass a pointer to the input, and then the game we're going to be a pointer to the input. And then here I'm going to test if we're also going to have macros to type less here. But the idea is input buttons button left dot is down. if is down and changed. So this is the pressed state, right? Now we should only have, I think it's going to be hard to see. Yeah, it's going to be hard to see because we are like in 1,000 million frames per second right now. So yeah, we can change the position, right? I'm going to do this. Okay, so this is pretty cool. Now we can just click to move the, like we're doing now. If I hold, nothing changes. Now if I do the, if I remove this part, if it's down, now if I hold it, you know, it's going to be crazy. Yeah, like this. Okay. Now, as you can imagine, this is pretty weird code to write. We want it to be simple for the game, right? Okay, that's the basic things we need to be able to do nice and clean input in our game. I'm also going to do a process button macro here. Just to see if we have a basic movement. Okay, and we do have a basic movement. That's pretty cool. Okay. Oh man, that's a lot. That's great. There is a small problem, which is we're not pixel dependent. What is that supposed to mean? That means if we have a very small screen, our player moves quite dramatically. So the basic thing we're going to do here is convert the units to pixel and call draw rect in pixels. And in a math, I'm going to create our vector2 class. The numbers look good. I'm not sure why I'm not drawing though. Okay, I did x, yeah. Okay, thanks for catching that, but okay. No, where did I get that wrong? Did x0 y1? Yes, okay, thank you. See, now I'm starting to reap the benefits of programming on stream because people do catch these errors. And these are the stupid errors, right? No one wants to spend our time debugging things like that. Nice catch, born villain. Okay, right? Yeah, human debugger. That's the best kind of debugger, right? It's just to offset the standard. Now, if I start the player at 0, 0, which is what I'm doing, I expect him to be exactly in the middle of the screen. See? So that's the first step. If I have a wider display, see, the size doesn't change. All it changes is the position, right? So I get more things on this side and on this other side as well. If I do that vertically, but if I do decrease the size, I do see the change, right? Okay. And the vertical is the same thing, right? Here I am gaining space, and here I'm changing the actual size. Hopefully that was clear. What I'm going to do is I'm going to now make the final thing we need, one last thing that I forgot to write here, but it's time. Time, okay? We need to know how much time passed between last frame and this frame, so we could do proper gameplay, let's say, frame rate independent movement. So this is the problem we have. If I change here from pressed to is down, this is going to, first of all, I'm going to be super fast, right? Yeah, super fast. But if I make it full screen, I don't know if you guys can see, I'm not as fast because I have to process more pixels, so a frame takes longer. So I'm doing this fewer times per second, right? Last dt is going to be equal to the current counter dot quad part. That's how this large integer is structured. Minus last counter quad part. This divided by, and I'm going to do the division in integer because it's has a lot of it's a very wide integer, right? Divided by the performance, the frequency counter quad part, and now I'm going to convert that to float. Okay. In the first time, the frame rate is the one we set up. It's 0.016. But if we run this for a time and then we breakpoint this, see the numbers. I think it's wrong. It's 0, right? We have to debug that. It's supposed to be very small, but not 0. We're going to do the subtraction in int and the division in float. So I might as well store this guy as a float, right? I'm going to do a frequency counter. Frequency counter. I'm going to store this as a float. Now I should now have. Wow, it's still too slow. Let's see. Okay, that's more like it. Okay, this is not a perfect movement system yet, because I think I'm going to use the mouse actually to make the actual gameplay. But for now, it will work just for a test of our systems. Now let's test. A very small screen should still be okay. It's approximately the same speed. In a super large screen, it's still the same. Okay, that was a lot, right? There's like 2.5 hours of streaming. So I'm going to wrap up this stream. And the next stream, which is probably going to be tomorrow, we're going to do the gameplay part. So if I go back to this plan, I can even type this in the game here. I'm going to type a to-do here, to-do. So that's the basic things. We already did the first, which is the initial platform layer. We are going to do the game next time, okay? So I hope you enjoyed this. If you do, be sure to follow me. You can follow me on Twitch. So you can, it's going to be a weird thing. Follow me on Twitch so you see when I stream next time. It's probably going to be tomorrow, but who knows. You can also follow me on YouTube, which is youtube.com/DanZaydan. And I'm going to post all the streams on YouTube if you want to rewatch it. And if you want to get the game, which is going to be free, you can go on itch.io, danzaydan.com, danzaydan.itch.io. And I haven't created it yet, but I'm going to create it now. And you can download it and have fun, with the version we have now. And if you want to expand on it, great. It's whatever you want to do with it, But next time we're going to focus on the gameplay, and that's going to be fun. So I hope to see you next time. Hope you enjoyed it and maybe learned a couple things. And I'll see you then.